I'm gonna go through setup on an OCD-3260, and what I've set up is this tool holder, is HSK, and grind this taper and this straight here, and I'll probably go through the programming too. I'll probably, thinking out loud, I'm gonna do the physical setup first, and then move on to the actual conversation programming. And so there'll be some editing here, and I'll splice these videos together and do the best I can. But what I have here, I'm driving with the cam driver here on journal that it's not ground, try and protect these surfaces here. But this is just, I'm not sure the size. It's a right and dead center bull nose. But what's significant is I'm actually, I've actually got this all locked here, where everything rotates. The part, the center, everything moves together. And I'll show you that. I'll take that apart and show you that. It won't take long. But this is a dead center, so this one stays still as the part moves on the tailstock side. And I have just one diamond set up. It's not coming in, there it is. Just a cheap diamond that I don't care too much about. But what I'm doing with that is I'm making a profile on the wheel. That's the actual taper. If you see the profile of the wheel, that's actually that taper there. And then, of course, I'm grinding this with the straight part of the 2-inch wheel. Right. So I know there's many that are familiar with this type of headstock, but so could be some redundant things said here. I'm going to take the driver loose here. It's attached. That's actually a M10 by 1.5. Actually, both are. Of course, this is all thread. I needed a little longer for this setup here, but anyway, so this comes off. Then I'm gonna tap out the center from the back using a longer soft rod. It goes through there. Here's something to remember. This knob here needs to be open. You don't want it locked in like that. You want to disengage that when you're running the live on the spindle bearings, and it's dead here, so it all spins with the spindle bearings. But you can see well, you can't see, but anyway, that's how you get to it and knock out the center. So with the headstock plate removed, it really was 7, these 4 out here, and then those 3. 7 screws to remove. We were able to get to what I really wanted us to see, and that's this driver key right here. You can see I can move it in like that, and it will spin only so it will only drive this driver here, and with it out, it will drive the center also, and that's what I wanted to do in this case. Really heavy part you'd want to drive that way too. Anyway, you can adjust Might be a good idea to adjust the, I don't know if I'll get there. I got it pretty close. If you can't, you might have to adjust your work spindle RPM a little slower. And that one says 87. And here you can, this is a ProFace control. Some have this, some don't. And you could adjust my RPM that way on my work head. With it lined up, with the keyways lined up, I'm able to push that out so it actually engages. And just tighten it up. And then put it back on, put the faceplate back on, put the center back on. Now, of course, this is a 10th indicator. I don't have a micron indicator with me, but as you can see, it's not terrible. That's about as far as I can reach. And I brought it out here closer to the front too, so I checked 2 places, and it's still just about the same run out. Now I got this part on the bench center after I ground with my setup. And let's see. I did that. Not bad. So I have my work holding back together. Put a little bit of high pressure grease in that center there. And this one all spins together, so this adjustment for the this is a spring-loaded tailstock, and that's an 8mm Allen right there, and I have it set pretty much all the way out. I'll go into tailstock thrust settings on a different video, but obviously it's important. You put too much force on it, and when the part comes in here, you can start bending the part, flexing the part. Not enough, well, we just wouldn't hold it, right? So anyway, here's that part. So I'm gonna go into some of the programming and conversation that we're gonna do. I'm gonna keep this video here, because a lot of this should be provided by your wheel manufacturer. Is going to provide your surface speed, and a lot of times a process will be worked out ahead of time. What parameters you use, depth of cut, speeds and feeds, work speed, that kind of thing. So here on the ProFace, I can set my velocity here. This is in meters a minute. You see, that's not crazy fast there. I think it's 25 meters per second. A lot of times people like to look at it that way. And work speed is set in a program, but this one here is set individually. So this is manual speed. So someone set it at 87 before I got here, but anyway, I usually look at this screen here on that. Now, so the first thing we do, we're gonna go to the work, and you'll want to, if you have not done it, you'll want to do a coordinate setup, a work piece setup. So this is saying we're going to start up the work. It already is started up, but I'm going to say okay. Now it's going to tell me, okay, come and touch on this diameter. So I'll go touch on it. When I finish this process, I'll measure it, and then I'll enter it in the final screen to set my work coordinate. Now, I'm one-handed right now because I'm trying to video with my left hand and do things with my right. But so what would we do? We come in and touch on a diameter. We'll know. We'll have to. Well, eventually, we don't have to know the measurement right now. We will need to know it to finish this process. So we come in with the wheel on. Here's my setting. This is two-handed, so both of these have to be pushed in for this hand wheel to work, for it to jog the axis or the axes. Anyway, you see we're down this here. So if we're in inch mode, which I am in, this here is 10 millionths. This is times 10, that's tenths. This is thousandths. And this is 10 thousandths actually on the screen when you move it. So like I said, 10 millionths, tenths, thousandths, 10 thousandths. So actually, when we're touching off the wheel, we want to touch off the dresser first. So if we go to wheel data, here is the dress condition page here. We'd go into coordinate set. Now I've already have this set, and since I can't have both hands, it's I can't. I'm gonna not actually touch on that. But what it's showing is touch right on the OD of the wheel. So I touch my diamond on the OD of the wheel. Number, you can go as slow as you want. Now these are pretty safe speeds. The times 1 times 10 are really slow, pretty safe. But go as slow as you need, and then I can usually see a glow, and that means that I've hit the wheel. The diamond kind of glows. So when I do that, I'll hit set, but I'm not going to do that now. I'm going to hit pass because I've already set this up. So I hit pass, and then it's going to ask, come down to the left side here. You can see this one is this first one is set pointing here. So that would actually be this guy right here, but I don't have one. I'm only profiling with one diamond because I didn't want any kind of blend mismatch. Sometimes you get, say this guy here, if you were to do a profile on a wheel like I am, this is a pretty simple profile, I understand that, but this diamond here will do a lot more dressing than this guy will, because this guy's going to dress a taper. This diamond will wear faster, so you'll have some blend mismatch. Even if you have it right from the beginning, eventually you'll have some mismatch. So to have one reduces that quite a bit. So, and then so pay attention to this orientation of the diamond. So then it says bring it to, yeah, and of course I'm going to go pass again. Then there's the one pointing right, and that happens to be the guy I have. And I do the same thing. I touch here, and then when I get done there, it wants me to touch on the right side. So I go in and I touch on the left side, I'm sorry. And then it'll probably ask me, yeah. So there's the other one. So in this case, I set them all. Since I only have the one, I set them all the same because I'm not going to use those right now. So if you had those, it would be a good idea to actually set these up. But I don't have those, and I'm not going to use the left or the front one for anything right now. So right now, these were all originally set using this one pointing right that I have in there. So I'm going to pass again. Please reset work coordinate. And execute. Yeah. So that part's done. So then we'll go to the work. And we'll want to set this up next, and it's coordinate set, and it says start work spindle. It happens to already be going, but anyway. And then we're going to touch. Now this part's already the size. I'm not going to touch, but once again I would just touch till I see some sparks, very very minor amount of sparks when I made contact. and then you'd hit set, and camera's not even in there. So once you touch that, you'd hit set. And then if you had a shoulder, you'd hit set. If you don't have a shoulder, go to where you want your wheel to start. And I want mine to start here. Matter of fact, I came in here on the grind stock part, and I touched, after I profiled that, I touched right here, just by jogging in the hand wheel, and I made my point measured off of this end here. And so that's where I set my 0. That was the easiest thing I could think of to do at the time. And then so once you get there, you'd hit set. And then if you had a right shoulder like this, then you'd hit set again, and you'd touch on that shoulder. But straight wheel, we don't really grind on shoulders, so you really just want to barely touch on a spark just to get your location. And then you'd hit set. I don't know the effect of this. So now it's going to retract. And it moved off, and it said it was done. And then here is where I'd put in. So in this case, my shoulder, I would say 0, because I went exactly to the shoulder. If it wasn't a convenient place to put to touch on, then I need that distance. Say if I touched over here on this side face here, I need to know that distance. I put it in right there. X, I need to know that diameter that I touched on. So I've been measure right now. Same thing with the left shoulder. So if there's a distance off of 0, I'd want to know that. If it's not, if it's right where you touched, leave it 0. And then you hit save, and it should be done. Now, so I'm not going to reset this up, so I hit exit, and it asked cancel setting, coordinate, keep original set. I say yes, keep the original. I don't want to change it. And it'll say setting unfinished. And it'll process, and then it'll be done. Okay. So let's go in and look at the programming. So I'll show you where it went. So hit the blue, and then we go to program, and go list. So here's programs I have right now. That means very little to most of us. This is the one I just did. And to add one, I would just say add, and then input a program number. Well, 8's available, so I'm gonna go 8, and then enter a name. Whatever you want to call it. I'm just gonna put 8 again. You can put a name or number or both, and then hit input. And now I'm in it. Now 8 doesn't have anything to it. I haven't added any processes yet. So I go to OPN, they're all blank. And so here if I go edit and I go create, now I can look at these different grinds. And so on that part, the first thing I did was this multi-plunge. Okay, so based on the wheel, I have 2 plunges, and then it grinds the fine and the polish and the traverse. So it plunge, gets rid of most of the material, and then it blends it together and does a really nice job. That's a good one that is used often. And so if I have it selected, you can see the windows kind of shadowed or whatever you call it. I hit input. Oops, I didn't hit input. There we go. So now it wants to know work diameter. Well, that's this guy. So what I'm using it for is right here. This happens to be this final size is 1 inch. So if I put that in, and I go down, and then so here, the first Z I just happen to program it this way. If it was off, a lot of people will use this, and I would normally, but I didn't want any measurement error to happen between here and here. So I just went in and touched it and called it 0. So I'm going to program it 0. So I say 0, cancel. Then input. And then the next one, what you can do is actually move your wheel over here to where you want it. And this is a full center here. You could probably use a half side center, and the more you could pull your wheel over and use it, the last little bit as the finisher, that's what you'd want to do. I didn't have that option with my setup. You come over, just bring your wheel over as far as you want it, and then you hit this guy right here, memory. And see that's a distance. It says grind position from, so it's 8 from 0. And it also calculates the wheel in there too, whatever your width is set of your wheel. And if you want to overrun, you can. I leave those, if you're programming off a print or something, put in your print numbers and then select an overrun. Be careful when you do this. Pay attention, do it in a single block, because you don't want, you could run into your tailstock or something like that if it travels too far over. Retract value. Now that's a diametral value. So if you have something to clear, say I had to get across over this guy right here, I'd want to put in my retract value. This is 2.5 inches. I want a retract value of more than that if I was going to come over. Of course, I can't do that on this setup. I'm not going to. But anyway, so that's what I would do. I'd put in a nice, safe retract value. You could put it as big as you want. 5 inches ought to be plenty. So that's the diameter it's going to retract to. And then I go in. These are default, and they're not a bad place to start usually. But like I said earlier, most vendors will help you out with this kind of metal removal rate. You need, whoever your wheel vendor is. And let's see. Let's go through some things. So total amount of stock right there. And so it's 20 inches of stock over diameter. And then it's going to start a fine grind at about 2 thousandths. 2 thou right there. 4/10 for a polish. Your work RPM's already decided. You can change any of this, all of this. Order. Say you didn't want to go so the interval, can you see the stagger here? That's what that's doing. Or if you just want to go order, so see that every depth is the same place. So that's what I usually do. I haven't had a need to do another one, but I might experiment one day with that. Yeah, so this here, both feed means it goes back and forth. You can select, make it go that way, or go that, or the other way. But I like both feeds, so to try, it's the most efficient. It's come down this way, feed in a little bit, come back the other way. I like that. Spark out how many times you want it to travel back and forth. Let's see. Well, I don't think I need to go through all of this, but you can, if you look here, they've got it identified by V's. So these V's here, and the 3V is identified down here. So these are correlated here, these settings. Yeah, so this is default values here. Escape amount, so I have no shoulder in my case, so I don't have to worry about putting in a shoulder amount. It's 0. If you had stock on that, you'd want to put that in there. escape amount, that's how much it's going to come back off to get over here to this arrow. And then again, right, you know, I like that because it'll start here and go here and then go there. So, and that's pretty much it. And then you just hit save and you say yes, and then I have a process. So I have that guy, and then I can create another one. So I say edit, and I go, I'm still in program 8, and I called it 8 and 8, and you hit create. And then the second thing I did was I went to this traverse here. Now this right traverse is what I went to. So what I ended up doing is I ground this first, and then I ground this, and it made a really nice blend that you can't even see it, matter of fact. So it worked out well. And if I go in and if I hit enter, here's the inputs I need. So I need a diameter to start with. So if I come up here, I start on here, but this is a calculation. So if I start here at 2.5, you could do that, but you need to know your angle. So, and you want it on center. You don't want included. So if you have a print saying included, divided by 2, so you get this, because that's really what it wants. Down here at R, and mine happens to be like 13.721. Where's the number at? There it is. That's the angle I want. And then you could actually even do a memory on these. You could touch, so you could go in and touch. So you got to start with it. So if I start at 2.5, that's where I'd want to. That's where I'd want to put it in my coordinate right here. I'd want it 2.5. So I'd bring it over there, hand jog it over there, and then in Z, let me put that in first. And then Z, that number you would want to come over here and actually touch the start point. Now I understand that's gonna be with stock on it, but that's a good place to start, because you could actually change your start diameter right there. But I prefer to have the whatever the print or final value is. So that one there, you could say, and it's from 0. So if this is 0, then this is -3 or something like that, because that's the way direction it is. You put in -3 there. These numbers are arbitrary, really. I'm not going to run this program because it's not proven. The one I'm going to run is the one I created, and I'll show it to you later. But I wanted to go through the program creation process on this one. And then so this one here, this would probably be best to do if you actually go in and use memory. So if I bring that wheel over here and then I hit memory, it will record that number and it'll do a calculation with the wheel, because yeah, so if you go hit memory, it will calculate where it needs to go. So that's probably the best way to do that. If your alignment's good, you probably don't need to use. If you were to, you can adjust that grind wheel head 30 degrees if you wanted to. So if you had some offset to put in there, you could do it for that reason. Retract value, it's the same thing. If you wanted to retract a certain amount, I don't have anything in the way, so I'm not going to do that. And then there's my default speeds and feeds. Actually feeds and stock. I don't have any speeds in there that I see. Yeah, I do, RPM. So use what you know. Most people already know what they're going to do, but there's the places you enter them. And then you just save. And then so from here, I would offset based on the stock, because I used my print values. Based on the stock, if I programmed off of touching it off and I had stock, you'd want to program the actual absolute values, and then you would just offset down. But I programmed off the print values, and then I just offset that stock. Now remember, this is just additional offset because in my program I put in the stock. So if we go here and look, see, so right now it's programmed for 20. And if you don't have that much, then you reduce it. But be careful and pay attention to what you actually have in these, because you'll run your wheel into your part if you're not careful. So I'm just gonna go left, and then I'll say save, and I'll say no because I didn't change anything. Okay. We're gonna go through a wheel setup actually. We go to wheel data, and we're in dress condition. Right now, this is what I have it set at. I have per pass dress off 8/10 at 10 inches a minute, dress one time, and allowance. Let's talk about that. So if you have a weird geometry, the allowance you put in will keep it off the wheel, and it'll gradually make. So when I did this, I put allowance of it was over 100 thousandths, whatever that calculation is, from this OD to that angle, and I just backed it all off and let it dress air, and just come in and gently shape this, the taper there, this profile. So that's what allowance is. So you come in and you put that, and then so it would keep on subtracting the 8/10 from the allowance first, and then once it got to 0, it would start paying attention to how many times you tell it to dress, and then your shape should be in your wheel by then. And if you go if we hit wheel, and here we're going to select, so here, if you had, usually your wheel comes with a measurement when it's new, or it should, and so of course I've dressed it so it's subtracted since then, but every dress it will update your wheel diameter. So this number here doesn't mean, this number here is of course the width. We see how it highlighted it there. It kind of it goes along. It highlights what you're on, what box you're on, for lack of a better word, right now. Minimum is 10 on that. That you'd probably want to put something. You'd want to change that to something relevant to what you need. And then here, this minimum width. So these numbers here don't mean anything to me right now. They're not really set where I should have them, and I'm not worried about it right now because I'm not using this grinder every day. So if we look here, we can select features of the wheel we want, and so a lot of times it's set to outer diameter, and you just have a plain wheel like this. But I'm interested. So here's a preset, and so it's got relief back here. It's got this radius feature on the side, and so if you needed that's nice. And then of course here's the right side just like it, and if you want both, so that's a good function or good feature to have. And so left taper, I end up using this profile one. There's a right taper one. I didn't use those because I wanted more control than that. So here's what I did. I did a profile. And so I'm using just the outer diameter profile. I'm not going to profile anything on the left face or the right face, so those are turned off. So here it says grind wheel type. I'm going to say profile, and I say outer diameter on. And this is my case. Now you may have features you want, but it's all relevant, so I can do this. This is a default speed, so you may want to change that based on size of your diamond and the grit of your wheel. Mainly size of your diamond. But
tool offset. I'm not really using that, so you could either turn that off or set it to 0 on the tooltip. But I left it on in case if I started seeing wear and I wasn't getting the geometry I wanted, then I could offset some tooltip wear. So my diamond wears right, so when it wears, it does some things to your dressing. It will decrease the accuracy of your actual geometry, and of course your speed too. You'll have to change it. As you get it more of a flat diamond, you'll want to go faster across there because you'll just be dull as you dress, and you'll be dulling your grits again instead of keeping them sharp. Anyway, yeah, so we've already seen that screen. I meant to go, if we page back down, I meant to go to wheel and page down, and so out. So this is where I describe what I want. So if we go here, start position, I always keep it off the wheel. This is 0, 0. Remember we touched off at 0, 0. We should have. And so you keep that in mind. And then I just put a really big amount to stay off the wheel. So I start over here. In this case, I'm gonna go this way, and it'll pay attention to what you're doing in the tool what it's called, wear compensation, tool radius compensation. And so this next line, these are actually distances or depths. They're not. This is not diameter here. So I'm gonna go minus. This is just that. This is just a calculation of that angle that I'm putting on that wheel and eventually putting on the part. But yeah, so it's 85, and then keep that one the same. I like a nice square box path here. So, and then we go over, and this is just kind of redundant, but I wanted to see it do it. So same X, closer Z, so it's right off of it, and then I go right on the side at 0 here, and then minus 73. That should have been the calculation. So then eventually I'll end up at 300 thousandths here, and then at 0 on X. So X, that's the surface of that's the outer diameter surface of the wheel. And then, so I'm across here 0, and I want to go minus 2.2 past the wheel because the wheel's around 2 inches. And then I come off of it here, so minus 2.2 in Z, but X is 0.3. And then to finish off, I come right back where I came from, right there. And then you just save it. If you've made changes, you'd save it. I didn't make any changes. And if you can select the line or radius, the speed, those are separate. But when you're in here inserting or modifying, it's going to ask you line right away. So if I want to go in here and modify, see, it will choose your type again. And then so you say line, and then it's going to ask for X depth. And then you say, you put something in. I'm going to hit cancel this time, but you put something in, you go right across here. Really, it just wants X and Z. And then say something was a little bit wrong, you have some control here. You can offset it. You can, if this wasn't straight, happens to be, in my case, it worked out well. But if you got some kind of taper, you could correct any alignment here if you wanted to. Alignment or just the location or where your features ended up. Anyway, I'm gonna say cancel. So that's that. That's the profile setup. So now let's use the dress cycle we created. Yes, yes. Of course, I'm not gonna have coolant on the wheel right now. Something to note, if you dress and your wheel's over here instead of home, it's going to return there, so expect that. It sometimes catches people off guard.
So we're ready to run our program. I go in here and I go list, and I say 7 is my proven program, so I'm going to say, even though I already have it selected, I say open, and I hit 7, and I hit input. It says delete offset value and measure data, and I say no. Profile address, and I say yes, execute, and there we go. Now you should be careful because sometimes it will delete your offset value, and it just has to do with where it's storing the data behind the scenes. I don't have a good explanation for you on this, but so check this. If you have, see, I have quite a bit of offset here because I don't really want to touch the part's already finished. So from here, I'm going to make sure it's in memory, and I look up here and I see program 7, grind program name, and then so from here I'm able to cycle start. And what I will suggest is you use your override and your single block control. Make sure you have things set up right. I mean, you don't want to plow in that. Everybody should care about their safety. So what I'll do is I'll first cycle start it, and then I'll put in single block, and then I just hit single block again. I should get it. It should go into my first process. Turn single block off for a second. Okay. Now it wants to come in. See, multi-plunge is the first thing it's going to do. And it's going to come in. So now I'm going to put it back in single block. And I see my distance to go. And I'm just going to slowly keep checking that. Distance to go. And then where it is. So I'll let it come in relatively close. And then I'll check the distance to go. See, I still have it in single block. So that it's not going to go. It's just going to go to this move. And then it'll stop. So it says I'm 2.86 away. In diameter, and that looks probably about right. So I'm going to go in a little bit more than that. And it looks lined up right. It says I'm 600 thousandths, a little more down away. Yeah, I'd say that's true. Plus with my offset, we're at 4. And we're at 0. And of course we're off the part. You don't want to be on the part at this time. It's going to feed into the part. And then from here I can just take it off single block, and I can hit cycle start again, and then you can see it's going to feed into the part 78 thousandths, 7/10, 40 minutes. Let's see. And that's running the cycle. And I'm not going to continue it because there's no reason to go into that or spend the time on that. But everything looks right.